On page 61 in our notes and moving on to the really interesting part of the class, this idea of statistical inference. So if you remember earlier in the semester, we had this idea of descriptive statistics where we just collect some data, we describe the sample that we've collected, hence the name descriptive statistics. Now we're moving on to this idea of inferential statistics or statistical inference. And statistical inference is moving beyond just describing the data, but taking that data and using it to make a prediction or an estimate about the entire population. Since we were just speaking about sampling distributions for one proportion, we're going to start with inference or prediction for one proportion. So before we get started, I have a motivating question here. Suppose our goal is to estimate the population proportion. Remember that notation for population proportion was just P, the proportion of the entire population. And the question is, what value from our sample could we use? So my first note here is to estimate the population proportion P. It would make sense to start with P hat. And remind ourselves, what does P hat stand for? P hat represents the proportion not of the whole population, but of the data. So P hat, the proportion of the data, or of the sample. All right, introduce a new vocabulary word here. This idea is, this estimate is called a point estimate. And the reason it's called a point estimate is because it estimates the parameter with just a single value. I'm going to highlight this term here, point estimate, important new vocab. We usually abbreviate it PE. So again, P hat is our point estimate, or a single number, a single statistic from the data that's going to be used to hit our goal or our target here of estimating P, the proportion for the whole population. That's our end goal. All right, second question on here though says, why is it not enough just to give P hat? I collected some data, here's the proportion for my data, done. Why can't we do that? Remember, we just talked about it for sampling distribution of proportions. What if Joey goes to collect data? What's going to happen? Right, he's going to get a different P hat. What if Susie goes and collects some data? What's going to happen? She's going to get a different P hat, a different point estimate, which is why we needed to know what those different P hats looked like in the previous section. So let's jot this idea down. I'll say it is not enough to give a point estimate alone because we have, again, this idea the point estimates are going to vary, and I'm going to use the abbreviation here, the PEs or point estimates will vary from sample to sample. Let me fix my handwriting here for you guys. Sorry, I'm still getting used to this whole tablet thing. Will vary from sample to sample. All right. So we're going to start with a point estimate. It's a good starting place, but we need to add some more to that and include this idea that we do expect some variability from sample to sample. So because of that, instead of giving a single value, we're going to construct an entire interval. So we have this concept called a confidence interval. The first phrase in this, confidence, means we're going to be able to attach some level of confidence to our estimate. We're 95% confident or 90% confident in what we're about to say. And then the interval part of this tells us that our estimate is not just going to be a single number, not just a point estimate. Instead, it's going to be a range or an interval of values. I'm going to describe this kind of in two steps. We're going to talk about the basic framework, and then we'll introduce it specifically for a single proportion. It's good to understand the basic framework because we're going to reuse this in different settings. Maybe we want to talk about the mean, or maybe compare a couple proportions or a couple means. So understanding this basic framework that's the same for every confidence interval will really help. All right, so I'm going to kind of go back and forth and do both of these at the same time. So for our basic framework here, the first piece we need is what we've been talking about, this point estimate. And this is just kind of our starting point. And the idea was to estimate the population parameter with a single statistic. So I'm going to say our point estimate estimates the parameter with a single statistic. Now think about this in terms of proportions. If our goal, and our specific goal in this context, is to estimate a single proportion, remember that notation is P. Our goal is to estimate P, the proportion for the entire population. My point estimate, or that starting place that we've already established, it's going to make sense to start with P hat. If I want to estimate P for everybody, let's start with P hat, the proportion from the data. And we just reason that's not going to be enough. Different samples are going to give us different P hats. So we're going to construct an interval around that. So plus or minus, this term we're going to call our margin of error. And our margin of error is always going to consist of two pieces every time. The first piece I'm going to call our multiplier. And our second piece I'm going to call our standard error. All right, so the multiplier, the point of this term is to give us our level of confidence. I mentioned earlier that we want to attach some level of confidence with our estimates. 90% confident, 95% confident, and so on. So multiplier, say, gives our level of confidence. And our standard error is going to be that part that takes into consideration, hey, if I take a sample, you take a sample, we're going to get different point estimates, and we need to include that variability that we expect between our point estimates. So standard error is the variability of our point estimates. Now let's translate that into our setting. So we're talking about estimating P, the proportion for the whole population. Our starting point or point estimate is going to be P hat, the proportion that we can actually calculate and estimate from our data. We know that's going to change from case to case, so instead we're going to give an interval around this. So plus or minus our multiplier to give us our level of confidence. The multiplier for this, and we'll explain in a little bit on an example, I'm going to call this Z star. So Z should sound really familiar. It's coming from the standard normal distribution. Again, I'll tell you how to find it in a moment. And then we need our standard error. So that part that takes into consideration the variability of my statistic. So how much are the p-hats going to vary by? We just finished talking about that in the last few videos. P-hats vary by p times 1 minus p over the square over n, all under the same big square root. Now we have a little bit of a problem here. Our goal is to estimate p, the proportion for everybody, but I don't know that value, so how can I plug it in for my standard error? That value's unknown. That's my goal or the thing I'm trying to estimate. So since I don't know that value, I'm going to plug in what I do know, the estimate from the data. I would highly recommend knowing this formula. So here's our expression for a confidence interval for a single proportion, and then make sure you also know this general concept, how to construct a confidence interval in general. We'll be revisiting this many, many times. Start with the estimate from the data, and then add and subtract a margin of error around that gives us our level of confidence and takes into consideration that our point estimate is going to vary from sample to sample. All right, in the next video, we'll check out an example of actually calculating a confidence interval and how to properly interpret that interval.